and welcome to Chapter 11, our final chapter of the semester. And our final semester, in our final chapter, we are covering NAT, the Network Address Translation Protocol. This is specifically only for IPv4 addresses. And we will discuss how it operates, and we will do some configuration. So we'll do a few configuration. We'll do a packet tracer together, and you'll be able to submit that. So this way you'll understand exactly how that works. And we'll go a little bit over the troubleshooting. It's mostly command line, so pay attention because a lot of the CCNA questions that come up always have some NAT questions in them. Okay, and let's talk about NAT. What really precipitated the IETF to get use the NAT and the private IP addresses? In the early 1990s, now around 1990, 91, after all the subnetting and doing VLSM, and we're still running out of IP addresses, they came up with the idea, why don't we just have a block of addresses that anyone can use inside a LAN? And if they need to get out, but these block of addresses, they cannot use them to access the internet. And I think we've discussed those in NET W203, the ones that starts with 10 and the ones that will start with 172.16.x.x to 172.31.x.x and the third one that starts with 192.168, right? So those are the block of addresses that were reserved. So as long as you are inside your LAN, you can use them and communicate however you want. And if you need to get on the internet, then there's a software that runs on the router. It's called the Network Address Translation. It's going to take your private IP address, remove that source private IP address, and give you a public one so you can access the internet with it. And when you come back, it translates back your public IP address and gives you back your internal private IP. So that's what the NAT is for. And therefore, as long as you are not trying to access the internet and you stay internal, you're not really using any of the public IP addresses. So you can have thousands of users in here. Design your LAN, and as long as none of them are accessing the internet, then you're fine. So this way we can serve a lot of IP addresses. In IPv6, obviously, everybody in here has a public IP address. They don't need private IP addresses to communicate with the outside world. They can use a public one, the one that starts with 2001, remember? They can use it and go right through. That's why we don't need NAT for IPv6. This is only for IPv4 to conserve the public IP addresses, right? So that's what NAT does. It actually translates the private IP address to public and back to private when it comes back. So this way we can serve a lot of IP addresses. And also, since your network is private and there's a router in there that interfaces the outside world, it really makes it more secure because people outside don't know what your private IP address is, and you're not going to use it when you are accessing the internet. You're going to use a different address, the public one, right? So here's your private network right here. And when you get out of here, then this is where you are going to be translated from private to public and back from public to private when you come back, right? All right, let's look at some terminologies. And from now on, we're not going to call them private IP addresses or public IP addresses. Private IP addresses from now on are going to be called inside local addresses. So inside local means private. Inside global means public IP addresses. So anything inside is in here, inside local and inside global. Inside global are the addresses that are inside the router that are going to be given to you when you're accessing the internet. So you're going to be given an inside global address. Outside is outside here. That's not our business. We're not going to be concerned with outside global. which is, remember, the word global means public, means you can use the internet. Inside means privately. Okay? So here, for example, let's say here's here's a guy that has a source IP address of 192.168, and his destination is 209.165. So when he comes to the router, he is going to be given the IP address, a public IP address, 209. Well, this is on the way back. He's going to be given 209.165.200.226, right? So the NAT gave him this global IP address. See, the destinations we don't touch. That's not our business for R2. But when he comes back, see this 209.165.226, then it'll give him back his IP address. So it's only the source IP address changes when it leaves. When it comes back and this guy's talking to him, it's on the destination, right? So he strips it back and gives it back to him. He has to keep track of everybody that got translated. Static NAT means you go to the router and you tell the router, listen, if you see the following address coming in, please give them this global IP address and let him go. It's one-to-one. So only one person, and you're going to identify that one, who that person is. Okay? So we'll be able to do static. We're going to do all four, in fact. I want to do all four static IP addresses with you. So he's a static. For example, this guy is the only one. This guy is the only one that's going to be translated to be able to access the inside server. Otherwise, don't translate anyone else. Dynamic routing is you create a pool of global IP addresses inside the router. So when the first inside local guy, the private guy comes in, wants to be translated, you give him one address of the pool and let him go. The next one, give him another address from the pool. Till you exhaust all the addresses in the pool, you have to wait till everybody else comes back. All right, so that's still costly. The best way to do it is to use what's called port address translation. Port address translations, you can use actually one IP address and then use the port number when they want to access the internet. Theoretically, the port number is 16 bits. So you can have, theoretically, 65,536 users can get on the internet using one global IP address. So even though NAT is one-to-one, but PAT could be one to multiple IP addresses. That's how you can have multiple users on the internet at home being able to access the internet at the same time. So PAT is what really allowed the IPv4 to be scalable. But the problem with NAT is the translation table. Every address that has to come in, you have to go through the translation table. So that takes a long time and creates a lot of delay. And that's a lot of delay for for application sensitive data such as voice over IP, streaming videos. That's not good. So that is really not a good idea when it comes down to that. So what are the benefits of NAT? It conserves the legally registered addressing schemes, increases the flexibility of the connections, provides consistency on the network, and of course, it provides security. But the biggest one is really conserves IP addresses. That's the whole idea behind it. That's where it came out. Now, of course, the big disadvantage of having NAT is that the performance is degraded because of the translation. Every packet that goes out has to be translated, and when it comes back, it has to be translated back. So that takes time. All right, and real-time communications is I have a big problem with that. All right, so how do we configure MAC? There are four different ways of configuring NAT. You can do static NAT when you do one-on-one, and the best way to do it, we're going to do all of these examples in Packet Tracer. So let's go to Packet Tracer and do the 4 different way of configuring NAT. So here we go. We are going to get a packet tracer, and let's get two 2800 routers and put one right here and put another one right there. Okay, you may call this R0. Call it R0, that's fine. And call this guy R1. Okay, you're going to need serial ports, so might as well go to the router, turn off the router, and put in a WIC2T right in here. Turn the router back on. Put another WIC2T in WIC2T in R1. Here you go. And let's mention in there the serial DCE. Let's use R0 as a serial DCE. Go from serial 000 all the way to serial 000. All right, I'm going to do 4 different networks. So I need, let's use a 2960 here and a 2960 there, another one 2960 here, and another one here. Let's call this, let's just call it LAN 1. Let's call this LAN 2. Let's call this LAN 3. Excuse me. And let's call this LAN 4. Okay. Let's connect LAN 1. LAN 1 fast Ethernet 01 to 00. LAN 2 switch fast Ethernet 01 to 01. LAN 3 to 01 00. LAN 4 01 to 01. Now let's get some genetic PCs up here. Let's put one here, one there, one here, and one there. Let's call this PC of LAN 1. PC LAN 1. Here you go. This is going to be called PC of LAN 2. This is going to be PC of LAN 3. And this is going to be a PC of LAN 4. Okay. Here, let's configure this. Fast Ethernet 0 to 02. Fast Ethernet 0 to 02. Fast Ethernet 0 to 02. And fast Ethernet 0 to 02. All right, we got to create networks. Let's create the link first. Let's give it a network. Let's make this 200 because I want it to be a global address, 200.100.50.4/30 network. Okay, let's go with LAN 1 network, and let's say it's 192.168.10.0/24 network. Let's say LAN 2 is let's say 172.16.100.0/24. Let's make them all /24, make our life a little bit easier. 1020 30 .0/24. And let's make the last one 12 13 14.0/24. Okay, first address to here, second address to the PC, right? So let's go to the PCs now. Click on the arrow here. Let's click the PCs, do the PCs first. Okay, go to desktop, and it's 192.168.10.2. /24. Just hit the tab key twice. It's 192.168.10.1. Okay, let's go to this PC and let's do 172.16.100.2, 172.16.100.1. Okay, double check, make sure you're typing these addresses correctly. Let's go to PC3, desktop, 10/20/32, tap, tap. No, no, no. It has to be 255.255.0, 10/20/30.1. Now we got to go back to PC2 because that's this should be /24, right? Although we could leave it. I want everything to be /24. Let's go to PC4. And PC4 is 12.13.14.2. Tap. Again, make sure it's 255. 255.0, 12.13.14.1. Okay, so .1 is the interfaces. Let's configure the router's interfaces. CLI, say no. EN, config T, make the host name. Host name R0. Host name R0. No IP domain lookup. Okay, let me go to interface. Interface fast Ethernet 0/0. And give it the IP at 192.168.10.1, 55.255.0. No shot. Go to interface fast Ethernet 0/1. It's this guy right here. Give it the IP at 172.16.100.1 space 255.255.255.0. No shot. Let's go to the serial 000. Right? It's this guy right here, which is, let's give it the IP at 200.100.50.4. Right? 255. No, what do you mean? Yeah, no, that's .5. Right? This is a network address. 200.150.5 space 255, 255, 255, 252. It needs a clock rate of 64,000, not 46, 64,000, and then no shutting. All right, let's go to router 1. Router 1, say no. EN, config T, host, name R1. No IP domain lookup, right? Okay, let's go to interface fast Ethernet 0/0. And the IP ad is 10.20.30.1. 255, 255, 255.0. No shot. Let's go to interface fast Ethernet 0/1. IP ad is 12.13.14.1. 55.0, and no shot on that guy. Let's go to interface serial 000, and then the IP ad is 200.150.6, right? 255, 255, 255.252. And all it needs is a no shut, and then everybody should be green, right? Now, the thing is, these guys will not be able to go to LAN 1, cannot go to LAN 3, LAN 2, cannot go to LAN 3, and so on. So that's a mess. We need a routing between. So what I'm going to do is I'm going to write a default route, because this is a stub network. Default route everything to R0, default route everything to R1 from here. Since we are at R1, so let's go and let's go back to the config mode. It's best to do that. Type IP route 00, the quad zeros, right? Space, quad zeros, space. Let's do the exit interface, serial 000, right here, right? Bingo. Let's do Control Z, show IP route, show IP route. And there's my static route, my 3 networks. Excellent. Let me go to R0 and do the same thing. Type exit. And let's say I say IP route, quad zeros, space, quad zeros, space. Now instead of using the exit interface, I want to use the next hop. I could do that. You know what? Let's use the exit interface. I don't want to, what the hell. It doesn't matter. And let's do Control Z, show IP route. And there you go. Let me see if I can PC1. I want PC1 should be able to ping PC3 and PC4. So let's ping PC3 first, which is 10.20.30.2. There you go. Good. And let me ping PC4, 10, nope, not 10, 12, 13, 14, 2. Good. And he should be able to ping by PC. He should be able to ping also PC and LAN 2, which is 172.16.100.2. Excuse me. And here we go. Okay, excellent. Now since he pinged and he went through the router, let's go to router 1 and type show IP NAT translations. There's nothing because NAT is not active and it's not being translated, right? So here's what I want to do. Let's do first number 1. We're going to do static. We're going to configure static translation. So what I'm going to do is there are 3 steps when you are creating NAT, when you are configuring NAT. First step is you're going statically NAT. You're going to do the translation, tell the NAT how to translate and who's going to get translated, and then go to the interface where that's the guy who wants to be translated, where is he coming from, which interface, and after he gets translated, where you're going to send him out from. Here's what you're going to do. Let's assume I want only PC2 to be translated, and I want him to be given a specific IP address when he gets out. Okay? I'm going to give him a global IP address. Has nothing to do with the serial ports. So watch. So you go to R1, go to the config mode, and you're going to say IP NAT inside source. You always write that. So what this is saying, IP NAT, that means you're activating NAT inside. When you have somebody coming from the inside and sourcing in, coming in, and he has the IP and he has the static. See, if you put the question mark, It's going, oh, did I write something wrong? Inside IPNAT, IPNAT inside source. I thought I wrote that, didn't I? Must have wrote something else. Okay, IPNAT inside source. So IPNAT. Anybody that's coming from the inside source, give them the static IP and static IP address. So now they want an IP address, the inside local. And what's his name? It's 192.168.10.2. And what am I going to give him? What IP address? I'm going to give him the IP address. I have to give a global IP address, right? Let's say it's 100.100.100.1. What the? I just made it up, right? So what this is saying is the following. IPNAT inside sources means if anybody comes in from the inside, coming in with this IP address, that's 1-to-1. So as long as his source IP address is 192.168.10.2, give him this global IP address. That's it. Anybody else comes in, don't translate them. Hit enter. Okay. Now, I have to identify where this guy is coming from. Where's the inside source? The inside source is fast Ethernet 001. So you type INT FA0/0, and then you say IPNAT inside. This is where the guy is going to be coming from. Now, okay, and the router says, all right. That's it. Okay, now I know where he's going to be coming from. After I translate him, where should I send him out from? Which interface? Well, it's going to be the serial 000. So I go INT serial 000, and I say IPNAT outside. Okay, is that clear? So three things you have to do. You have to say which IP address is going to be translated to which public IP. This is the command to do it. Then you got to identify where he's coming from, inside source, and where he's leaving from. That's the third thing, right? The 000 source. All right, so now that's it. So Control Z. Now let me go and ping PC. Let me take PC2. I'm going to show you something. This guy doesn't get translated. I'm going to have him ping PC3. So let's go to PC of LAN 2 and ping PC3, which is 10.20.30.2. Okay, it works. And now if you go to the router and you type show IPNAT translation, just write trans. Now, so this is from the old one. Let me clear IPNAT translation. Incomplete command. Okay, they want us to write more. Star. Oh, we have to put a star, of course. Now it's clear. Now if I type show IPNAT trans, that didn't do it. Packet tracer sucks. It's not showing it. But you see, because I pinged before, he already got translated. See, his local IP address packet tracer is not that good with that. Oops. So who got the inside global? The 192.168.2. Right? Yeah, in fact, let me ping again. See if that does anything. You're supposed to do it 4 times now. If I go back to the router, it's supposed to translate them 4 different. Well, actually, it's 1-to-1. It's a one-time deal, right? Only one of the packet gets translated, and that's it. Now, let's do a dynamic routing. Okay, let's create. Let's do the following. Let me get another PC. I'm going to get another PC right here. and I'm going to hook them up to here, fast Ethernet 03. Okay, and I'm going to give that the IP address 172.16.100.3. Should be 255. 172.16.100.1, right? So when I'm going to go to the router, I'm going to say these are going to be the inside local, right? By the way, that was one-on-one. Now let's do dynamic NAT configuration. That's the second part, dynamic NAT. So dynamic NAT says the following. This is how you do it. Do config T first. First of all, you have to create the pool of addresses. So let's say IP NAT pool, and let's call it NAT W1, right? And now they need the addresses. The pool is going to be from, let's say, no, we can't, let's say 150.150.150.1 all the way to 150.150.150.5. Let's just, the pool has 5 addresses from .1 to .5, and it is going to have a net mask. That's how you do it, net mask. And let's say it's 255.255.255.192. Okay, enter. I just created a pool. So the first guy that comes in is going to get the 150.150.1. The second guy that comes in, he's going to get 150.150.150.2, and then .3, .4, .5. 5 guys are going to be translated, and it's going to grab IP addresses from the pool. So now you create the pool, right? Then you're going to say IP NAT inside source. Okay, so if anybody comes in source, well, actually, I have to create a list first. Oh, wait a second. Now I got to create a list on who is going to be translated, right? So I'm going to say, let's do an access list. So you're going to say IP access dash list, and I'm going to call it NAT dash list 1, just the first one. Or we're going to call it standard. Standard. It's going to be a standard list. So what I want to do is I want to make up a list to say who's going to be permitted. So you're going to say permit. What's their source IP address? It's 172.16.100 with a wildcard of /24 as 000.255. Oops, permit. There should be a .0 here, right? And 30.255. Good. So what we're doing right here is you created a list, and you're saying permitted anybody that has IP address starts with 172.116.100, right? And then you created the pool already, and then you're going to say IP NAT inside source. So what you're saying to the router now, anybody comes in and trying to look for an IP address, all right? Please look at the list that's called, what is it called? NAT-list 1. And if they agree, then go to pool called NetW1. Right? So here's what we did. Hit enter. Here's what we did with NAT. First of all, we created a pool of global IP addresses. This is how you do it with the network mask with /26, right? And we called the pool NetW1. Then we tell the router, listen, we're going to make a list of who is allowed to be translated. So this access list right here, actually here's the access list called NAT list 1. And it's inside, it says permit Anybody that starts with has the address 172.16.100.0/24. This is the wildcard, right? Remember, I didn't write anything underneath that access list because by default, they're going to be denied, right? So now, then I go to NAT and I say IPNAT inside source. If anybody comes in asking for an IP address, please check the list called NAT list 1. So that means when somebody comes in, wants to be translated, the NAT is going to check out the NAT list 1. He's going to, hey, is your IP address starts with 172.16.100? If it is, then I'm going to go to the pool called NetW1 and grab you the first IP address and you get out. If another guy comes in, I'll give him a second IP address, which is .2. And another comes in from here, the third IP address. What we're going to do is we're going to have these two guys come in. He's going to get .1 and leave, and he's going to get .2 and leaves, right? But when he comes in, because we did a static, he's not going to get any IP addresses from the pool. He's going to get it from the static one, right? The other one, which is the 100 guy, correct? But now that we did this, now we got to tell the router where's the source coming from. So I'm going to say in int fast Ethernet 0/1. That's where the IPNAT inside is, right? And where's it going to be translated for? Internet serial 000. That's where the IPNAT outside is. Okay, so no, that's it. We're done. Now let's do Control Z. Control Z. And show IPNAT trans. Okay. I don't know why it doesn't clear it. That sucks. But anyway. Now let's go to PC2 and ping the 30.2, this guy. Okay, he goes through. Now he should be translated and getting the 150 guy, right? So let me go in, hit the upper arrow key, hit enter, bingo. You see? Bing, 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 the .1. 1, 2, 3, 4, and the 100 is still there. Let me go to PC4, and let me see if he can ping. Now, only 4 addresses already got translated. So this guy probably can only get 10, 20, 30.2. He's probably going to translate only one of those, not all of them, right? Because there's only 5 in the pool, and 4 of them are already being given out. So I go in, hit the upper arrow key. Oh no, they gave me 1, 2, 3, 4. You see the 150.2s, but it's still using port addresses, but that's okay. You see that? So that's dynamic routing. Now, if he goes in, he doesn't get the 150, this guy. In fact, let me put another PC in here. And that other PC that comes in, he can put it, if you put him in here, he'll get translated. But if you put him in LAN 1, he is never going to get translated. So let's get another PC just for testing purposes. Put it right here. Okay. And connect them. Right. And let's go give him the IP address 192.168.10.2. 1 is given, .3, right? 192.168.10.1. Right? Now, wait till he turns green. Let's see if he can, we're going to have him ping. He can ping anybody, by the way. He doesn't have to ping 10, 20, 30.2. But since we are doing it, might as well do that again. Let's ping 10, 20, 30.2. And it replies. Now, he should not be translated at all. So if I go and hit the upper arrow key, and no translation for this guy, right? Actually, only the old guy's still in there for some strange reason. And the other two, the dynamic ones, are just done, and it's not static. See, this is static. That's why it stays there forever. It's never going to change, right? These are dynamic, means They don't change for, you just do it once and they'll lose them and then the next guy can come in. But anyway, this guy, PC5, didn't get translated. Only PC1 will be translated. He was able to ping, but, this is just, the internet doesn't allows them to get out. All right, now, let's go on this side. Now what we're going to do PAT. So what we're going to do is we're going to ask PC3 to use the serial port to get out on the internet, right? Serial. This is a global IP address. Since it's already facing the internet, use that IP address. And what's he going to do is he's going to use a port number and give it right next to the IP address and get out. The next guy will use the same serial number to get out on the internet. And the third guy will use the same serial number with a different port. Okay? Okay, let me show you what I'm talking about. So let's go. And I just want this LAN, LAN 3. So anybody in LAN 3 will be translated. So first of all, do en config t. So let me do IP access dash list standard. Okay. And let's call it NAT list 2. I want to only permit the network 10.20.30.0 with 0.0.0.255. That's all I want to permit. Only these people. Oh, NAT list, there's no dash. Remember that. Okay, now I'm going to say IP NAT inside source. These 4 words says to NAT. If anybody comes in looking to get out on the internet, looking to be translated, this is what you say. If anybody comes in, wants to be translated, please go to the list that is called NAT list 2 and check him out. Validate him, authenticate him, make sure he's allowed to be translated. In other words, make sure that his source IP address starts with 10.20.30. And if that is the case, please go to the interface serial 000 and give him that IP address that's there and overload it. See, the word overload means attach a port number to it. That's it. And the next guy will again get the same IP address as a serial and will be able to get on the internet with a different port number. All right, let me go to the INT fast Ethernet 0/0. That's going to be the IP NAT inside. Oh God, I can't spell. And I'm going to the serial 000, and that's going to be the IP NAT outside. All right, so let's do Control Z. Type show IP NAT translation. Nothing, right? Let me go to PC3 now. Remember his IP address starts with 10.20.30.2. Let him ping PC1, right? Ping 192.168.10.2, right? Now he's going to be translating using PAT. That means he's going to be given the IP address 192.168.10.2. Oh God, did I write it wrong? No, I wrote it right. 10.2. It's timing out. I must have wrote something wrong. I'll bet you 10.20.30. Let me see. IP config /all. Let me just verify 10.20.30.2. 10.20.30.2. Okay. Let me ping again. 192.168.10.2. How about, if that doesn't work, I want to try something else. It's timing out. Something's not responding. Okay, do Control C. Let me ping 172.16.100.2. Unless that doesn't work. Okay, let me see what the translation does. It does translate it though, and they get out. Oh, of course. He's not going to respond back because NAT, that's a packet tracer, by the way. It's fine. It's just because when it comes back, it doesn't know how to translate it back. Packet tracer doesn't know how to do PAT very well. It knows how to do the dynamic NAT, but it doesn't know how to do PAT. All right, but it is, as you can see, here's your ISMP. Look, it has the 200.150.6. That's this IP address. And these are the port numbers. See, the chat is different port numbers to every ping it did. Right? And the inside local that was pinging is this guy, 10, 20, 30. You can put another PC in there. Let's put another PC in there. And connect it. Give it the IP address 10.20.30.3. 255, 55, 255.0, 10.20.30.1. Okay. I want to wait till it turns green, then I'm going to ping. Let me ping 172.16.100.2. Okay, it's not going to ping because when it comes back, it doesn't respond. It doesn't know how to translate it back. That's the problem. Trust me, it's a packet tracer issue. It's not because if you go to the router and hit the upper key, have the IP NAT, here's the translation again. So far, 3 of them got translated here. See different port numbers, and the source is the 3, right? The inside local. And where is he going? To 172.16.2, right? And that's the outside global of it. So you can actually do the same thing with here. Let's do another one, dynamic overload, it's called. So what you're going to do, instead of using the serial interface, we're going to create a pool of addresses. So let's do that. Config T. Say IP, well, first of all, let's create the pool. IP NAT pool, let's call it NAT W2. And the pool is going to be called NAT W2, and it's going to be 250.250.250.1 all the way to 250.250.250.16. What the hell? And it's going to have a net mask of 255, 255, 255, 240. Why not? And we should be at least 255, 255, 255. Oh God, 250. What am I doing here? Full net W mask is too small. Okay, we'll make it 224. Whoops, 224. That gives me more IP addresses because 240 gives me only 14 IP addresses, and here I'm trying to do 16 in the pool. All right. Okay, so here's the pool. Then let's do an access list of who's going to be allowed. So IPNet list, let's just say the list is going to be LAN 4. So LAN 4 is, let's go to the standard. Let's call it NAT dash list 3, right? And it's going to say permit network 12, 13, 14 dot 0 with 0.0.0.255, right? So now I created the pool. I created the list of who is allowed to be translated, permitted to be translated. Now I got to tell NAT what to do. So you say IP NAT inside source. So again, if anybody comes in asking for to be translated, please go to list called NAT dash list 3 and authenticate him. Make sure his IP address starts with 12.13.14. And if that is the case, then please go to the pool called NetW. What is it called? NetW what? NetW2. Grab the first IP address, but overload it. So this is Dynamic PAT, right? Enter. That's it. Now I go to in INT fast Ethernet 0/1, right? This one, that's where the source is going to be coming from. And you say IPNet into INT fast Ethernet 0, and you're going to say IPNet inside source. Oh God, not all together. IPNet inside. That's it. And then you go interface serial 000, which is this interface, and you're going to say IPNet outside. That's where you're going to be translating them from. Okay, do Control Z. Let's do the IPNet translation. It's empty, correct? Beautiful. Let's PC4 ping 192 guy. Let's ping 192.168.10.2. Okay, the PAT thing doesn't work as we said. Now, let's go see the translation. Hit the upper arrow key again to repeat the command. And bingo, you see? The global address from the pool was given to him, 250.250.1 with different ports, right? And who is pinging? This guy. The source is 1213.2 guy. Isn't that cool? Now let's this guy ping whatever he needs to ping. Okay, he's pinging, so let's repeat the translation. All right, isn't that cool? So you got the 1020 30.2. See, there's more of them being translated now. This guy goes from a different pool. He's getting the same, right? He's getting what? The serial port, right? Because that's PAT without. These guys are getting PAT without the pool. These guys are getting PAT from the pool, so he gets different, right? The 250.1. And this guy is getting the 250.6, the source. I mean, the serial port. The 250 is from the pool for this guy. All right, so now you learned the 4 different ways of configuring PAT. We did static on this guy. We did dynamic static from a pool. Then we did one-on-one the serial port PAT on these guys. And we did PAT with a pool. Dynamic PAT it's called. All right. So save this. You're going to put that as homework, right? So now you know how to configure the 4 different types of NAT. All right, so let's continue with the slides. Back to the slides, configuring static NAT, just like we did, right? He's the source IP address, and this is what the global IP address will be. You go to the serial interface, serial 000, that's where the inside source is. And this is where the outside is going to be, IP NAT outside. right? Assuming we did the IP address, we did that. Okay. So when you come in, you're going to be translated, and when you get out, show IPNAT translation. You show your translation. If it's static, it's going to be there. Will always be there. Okay. Verify it. You can actually clear should clear that, but we didn't do it for us, right? This packet tracer, for some reason, has few glitches. On the rerouter, it's supposed to work. Show IPNAT statistics will do that too. Okay, the dynamic NAT, that means you're gonna grab some you're gonna create a pool first, remember? So IPNAT pool, you give it a name, then you type in the pool range with the net mask, remember that? Then we created an IP access list, right? I showed you how to do that, the dynamic NAT. You can use show IPNAT translation verbose, which means a lot of details, right? I don't know if you need to do that or not. But here's PAT, IPNAT pool. Create a pool first, right? And this pool is from 226 to 240 with a net mask of 224 at the end, right? Create an access list. I use a named access list, right? They're using the numbered ones here. So he says IPNet inside, go to list number 1, choose the pool and overload it. We just did that, right? Just a few minutes ago. Instead of actually grabbing the IP address from the serial port. Otherwise, if you want to do that, you don't have to create a pool. You still have to create the access list. But if you don't create the pool, you just go, hey, if anybody you validate them with the list number 1, then you just type the word interface serial 010, and then you write the word overload. You still have to indicate where's the inside and where's the outside NAT interface. Okay. All right. So those are the access lists. We did all of that, right? We did PAT and show you how it worked, right? You can validate that show IP NAT translation. We'll do that for you. Port forwarding, for example, you want to open up a port. Port forwarding is the act of forwarding a network port from one network node to another network node. So a packet can send to the public IP addresses in a port router can be forwarded to private IP addresses and inside the network. This is when you go to, for example, let's say you went to a website and you want to play a game and you were able to access that website, and then when you start playing the game on that website, it tells you that you need to open up the port on your router. So you go to your router and you go to port forwarding and you type in the port number to allow the port to be open so that you can play your game, right? That's what really port forwarding means. We usually don't, yeah, you do it right here. So this way you can do it in your Linksys routers. If you have, you can just go in there in the GUI. You don't have to type in any commands really. Okay. Now, you can do configure port forwarding using the TCP. Here's IPNet inside static, the TCP, this port 80 to port 8080. So you're opening up port 80. So if you see the IP address 80 and 8080 will open up for them. You could do that too. All right. NAT for IPv6. Really, like I said, we don't have NAT for IPv6. Although they may be used, it may be used, but for a completely different reason. Why you don't need NAT? Because everybody is given a global IP address and all the data, and you can use that global IP address to get on the internet. And as you can see, we have more than enough. I don't even know how to pronounce this. Undecilen addresses, 340. That means 2 to the 128. That's a lot of IP addresses out there. So we don't need to conserve any IPv6 addresses. We have plenty of them. And all the data that leaves the private LAN is secured anyway, so there is no need for it. Okay, but IP, and we do have something similar to private IP addresses. If you want to go inside your network, your site, and just use a unique local addresses, something similar to the private IP addresses, and you don't want to be able to get on the internet with those and be able to route between the networks inside your building, you use the unique local addresses. They are the one that starts with the FC to FDFF. We haven't used it because we always use the link local only, right? The one that starts with FE80, remember? But you can use the FC00 all the way to FDFF, and you can subnet it, and everybody is happy. But there is no need for NAT. Now, NAT also uses IPv6 also uses NAT, but in a very much different way. I mean, it's not to translate IPv6 to give you a public IPv6. There's no such thing. It just allows you to have transmitting communication between IPv6 and IPv4. Okay, to allow, so this way when you are getting on the internet, it translates IPv4 to IPv6 and V6 to IPv4, really. But it's not meant to be permanent. It's just a transition mechanism. So it's only there temporarily till everybody switches to IPv4, right? So it's really translating IPv4 to IPv6 and vice versa. So if let's say you have IPv6 address, they give you an IPv4 number, you get out, get happy, do whatever you need to do, and you come back, they give you IPv6 and you come back in. That's if everybody that you're communicating only knows how to speak IPv4 on the other end. Okay, troubleshooting NAT, you can always clear the NAT translation, ping someone, show the statistics, see if you can actually, and you can show IP translation always will tell you how you are being translated. That's the best command to use when you are troubleshooting NAT. You can debug IPNAT and see the time, the source IP address that's being translated, what that IP address, what global IP address was given to, and where is that packet going to? That's the destination. These just are codes. These really nothing. These numbers right here don't mean anything. And that's it. So that's NAT. And that ends the semester, believe it or not. So please submit the packet tracer file as the homework. That's the only thing I'm asking for, right? This guy with all the configuration. And we'll be studying for our CNAT, CCNE, right? Our CNAT is going to be the new exam for replacing the first 2 semesters. So anyway, we'll talk about that in class. So please keep up with your reading. Don't forget your packet tracer files. And until we meet again in class, I'll see you. I'll see you in class. Be ready to do the hands-on. All right. Until then, God bless.